Why is my screen shaking? I don't know. Okay, so here we go. So centripetal versus centrifugal force. So this is basically number 5 off today's worksheet. Okay, so what I'd like you to do is, like I say, visualize top view of a road. So here's a road with a curve in it. Good? All right, and so what's going to happen is our car is going to drive around the corner. All right? So we have X-ray vision, and we can see through the car and see the back seat of the car. Okay, so that right there represents the back seat of the car. You're looking down at it. Okay? Sitting in the corner of the back seat is a bag of groceries, which you have just purchased at the store. So this little circle here represents a bag of groceries. Good? Does everybody understand what the drawing represents? All right. Now, using the genius of time-lapse photography, we are able to mark the position of the back seat of the car at different intervals as the car goes around the corner. So right now, the back seat is here. A minute later, it's going to be here, 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 right? As it goes around the corner. Follow? So a small fraction of a second later, the back seat will be here. A fraction of a second later, the back seat will be here. 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 You got to keep drawing them. Lots of rectangles, I know. These are all supposed to be the exact same size and shape. They're just turning as it goes around the corner. I'm doing the best I can to draw them uniformly. There we go. I will pause as everybody draws a whole bunch of rectangles. What's wrong, AJ? You good? Okay. I don't know, you were just making a scrunchy face. You look like you were debating putting your hand up in the air. I don't know. Because I like you. That's why I call it. All right, everybody good? All right, so before we go any further, what I want you guys to understand is this example is almost identical to the car driving into a brick wall example. Okay? So in that example, we talk about a car driving into a brick wall and you going flying, right? Okay? Abby, yesterday I was talking to you about the box of donuts in the car, right? This is kind of that same idea, okay? So, you drive your car into a brick wall, you're driving along at 60 miles an hour, and what we care about in this problem is the car and you, right? So, what happens to the car?
It stops.
Stops. Why?
Because the wall exerts it.
Because there's an external force on the wall, right? Or an external force from the wall. The wall puts force on the car stops quickly, yes? But you, inside the car, or the box of donuts on the seat in the car next to you, does what?
It doesn't have force to
Keeps moving because there's not enough force to prevent it from moving, right? Not enough static force, static friction on the donuts, not enough force on you to prevent you from moving, so you keep going at a constant velocity, yes? Okay, so this is basically the same thing, okay? With the exception that here, the sudden change in velocity is not going from moving to not moving. Now the sudden change in velocity is from going forward to going this way, right? The car's turning. Okay? So, let's talk about the car. In terms, and remember, one of the things you have to do is be able to identify the centripetal force. So somebody identify the centripetal force which allows the car to go around the corner.
friction.
Okay, friction is one word. We need to remember there's 4 things. So, friction from, I need an object, friction from the road, pushes the car or the car's tires inward, right? Good. So, the car turns because friction from the road pushes the car's tires, or you can just say car. Which way?
Inward.
Inward. So let me pause there for a minute. Is there anybody who's confused by that statement? Yeah.
You didn't draw the groceries?
I'm going to.
Okay.
I'm going to. That's yeah, we're getting there. Yeah, if you are, yeah. Okay, so, okay, so let's draw in that force. So here's the force of friction. Oh no, undo. Undo. There we go. Force of friction. 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 Good? Problems. So all of those little red arrows represent the force of friction at any given instant pushing the car inward. Cool? Alright, so this is Grove's point. People have fancy cars, and fancy cars have leather seats, and leather seats are slippery. So my groceries here are sitting on the leather seats in the back of the car. So, everybody point for me. At this instant where I've drawn the groceries, which direction are the groceries traveling in?
Away.
Point for me. Point for me. Aren't they going that way? Alright, now, the point of the discussion about the leather seats is it means they're slippery, there's very little friction. So more or less, the net force on my groceries is going to be zero-ish, or certainly less force of friction than you would get from between the tires and the ground, right? Okay, so look, this green dotted line, if the net force on the groceries is 0 due to no friction, they will follow this path. Why?
It's like the leather seats can't provide force to prevent them.
So no force means, think back to the first law,
Constant velocity.
constant velocity, right? Constant velocity means you don't speed up, you don't slow down, and you don't
Accelerate.
accelerate. But what are the three ways? Speed up, slow down, or
Stop.
turn, right? Change direction. If there's no force, the groceries won't change direction. They'll just go in a straight line. They'll follow that dotted line that I drew there. Follow? So here's my groceries. So Weston asked a minute ago why I didn't draw in the groceries. The groceries don't follow the same path as the seat because there's no friction on the groceries. So the groceries just go in a straight line. What did they do? Where are they now?
On the other side.
On the other side of the car. Was there a force pulling them across the seat?
No.
No. Why did they go to the other side of the seat?
There wasn't a force.
There isn't a force on them, right? They just go in a straight line because of the first law, inertia, right? Follow? Okay. Then, once this happens, now where are they? Like they're on the other side of the seat, so what's going to happen now? Are they going to keep following the straight line?
No,
No, why not?
because it already hit them.
Now there's a door pushing the groceries inward. Cool? What are you guys giggling about over there?
Just a really funny physics problem.
Okay. All right. Does this make sense, you guys? I like this drawing because it illustrates. A lot of times people wonder, like in the salad spinner, why does the water go to the outside edges? Well, this is why. The water's already moving, and so it keeps moving in a straight line until it hits the walls, and then the walls will push it until the water comes in contact with the hole. Follow?
Yes.
All right. What if the seats were a little bit stickier?
It may stay.
It may stay, right? There might be enough friction for them to turn, right? Okay? When's the breaking point? When do they slide? Well, the idea is there's a maximum force that friction can exert, right? Therefore, yeah, the maximum static friction, right? So that means there's a maximum acceleration that you can have, right? So if the car's acceleration is bigger than that acceleration, that's when the groceries fly. Does that make sense, you guys? But is there ever anything pushing the groceries outwards?
No.
No. Which brings me to centrifugal force. So before I get to centrifugal force, are there any questions about the point of this? Maybe I should highlight it by saying this. Uh-oh, we're going to run out of room.
I can't read that.
Weston!
It says groceries outward. Nothing is pushing groceries outward.
Nothing is pushing the groceries outward. And I wrote it in giant, fancy, crazy font letters
I love your jeans.
because it's super, mega, crazy important. Does this make sense? I just got these new jeans. I used to do the boot cut, and I switched to the skinny jeans because that's what kids are wearing. All right. I miss the boot cut, though, frankly. All right. Are we good with this? All right. So let's talk then about centrifugal force. Anybody taking biology or like AP Bio? Do you guys have a centrifuge?
Oh, yeah.
Yeah, spin stuff.
It spins stuff. So, okay, so a centrifuge is this thing. So you take liquid samples and you put them into what's called a centrifuge.
Oh, it separates them.
And then you spin it really fast. It takes these little beakers and it spins them and they go. And what happens is, like Weston said, it separates them. It takes the heavy matter that's in the liquid and puts it at the outside. So if there's like, I don't know, some sort of heavy deposit or something in the liquid, it goes to the outside and the lighter stuff stays on the inside. Okay, and it's called a centrifuge. And a stupid biologist would say, oh, that's because of centrifugal force. Okay? There is no such thing. I'm just kidding. Mr. Adams is one of the smartest people in the building. So, no disrespect to biologists. All right, so look, centrifugal force. You should write this down.
Writing.
Centrifugal force. I'm going to write a really dumb thing. So, centrifugal force is not a force. Just like a glove box is not a box. That's weird. Glove boxes are boxes. I don't know why I just said that. Somebody come up with a better analogy.
Boston cream
Strawberries
pie is
aren't
not
berries.
a pie.
Wait. Yes.
Boston cream pie is not a pie?
What?
Strawberries aren't berries.
Strawberries aren't berries. There you go.
Wait, yes they are.
I don't know. All right, anyway. So, it shouldn't be called this. All right, if I had a time machine, here's the one thing I would do if I had a time machine. Okay? Maybe like fifth on my list. Fifth on my list, if I had a time machine, I would go back and I would find the first person who said the words centrifugal force and punch him in the nose. Okay? Because centrifugal force is not a force. All right, so check it out. When you're driving your car, when you hit a brick wall, is there a force that pushes you forward? No. When you go around a corner in your car, is there a force that pulls you to the outside? No. But somebody who doesn't know physics will say, oh, when you turn the corner, centrifugal force pulls you to the outside. No. It's just a feeling. In the same way that when you stop your car quickly, you feel like you're being forced forward. If you turn quickly, you feel like you're being pulled outward. And some yahoo somewhere in history decided to call that centrifugal force. It is not a force. Okay? Oops. It is an apparent force, i.e. a feeling, which occurs, here, let me say this. Feeling of being pushed or pulled outward when I'm going to say your frame of reference, your surroundings, your environment. Let's say environment. Your environment is changing direction, or I'll just say turning. Cool. All right. So it is not a force. I will never, ever, 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 ever ask you to calculate centrifugal force because it's not a real thing.
Well, you could then say like.
I could, and then I would.
If we calculate something.
Then it'd be wrong, right? So yeah. If the only correct answer would be can't. All right. Cool, you guys. Any problems with centrifugal force? Okay. A little bit of entomology. Is that it? No, that's insects, isn't it?
Yes.
What's words?
What's word?
No, when you like the background of words.
Linguistics.
That's not exactly the word I'm looking
That's like
for.
studying.
I'll go with linguistics.
Oh, origins? That's
Yeah.
dumb.
The origins of words. There's a word for the origins of words. Wordology. Okay, a little bit of wordology for you. All right. So the word centripetal, the Latin root of the word centripetal, means center. Pedal means seeking. Center seeking. Centripetal force seeks the center, goes towards the center, right? Whereas centrifugal, fugal is like a fugitive. What do fugitives do? They run away, right? So that is center running away, center escaping, okay? Center fleeing, okay? All right, questions about centrifugal force? Okay, we got new numbers 8 and 9. Cool? I'm going to start with number 8, if that's all right.
Oh, I know about Vietnam. Sorry.
Okay, here we go, number 8. Or what did I just say? I'm going to start with number 9, if that's okay, is what I was trying to say.